suppose happens when a gas is heated but the volume stays the same? I think the answer is to be found somewhere in this 19th century steam locomotive. Before you show me how to drive this train, what exactly do steam locomotives have to do with gases?
Well, Cindy, at 100 degrees Celsius, water becomes steam. And it's this gas that makes the train move. Let me show you. Look, down here's the burner. Fuel oil flows from the tender car, is mixed with air, and burned. Now the flame transfers some of its energy as heat inside the boiler. And when the water reaches a temperature of 100 degrees Celsius, it becomes steam.
So to start moving, all we have to do is boil some water?
Not exactly. You see, at a temperature of 100 degrees Celsius, the steam exerts a pressure of roughly 1 atmosphere. And at that pressure, the gas isn't going to do any work. It's only when you have a pressure that's higher or lower than atmospheric pressure that you can make things move. Okay, let's increase the temperature by adding more fuel to the fire. Here we go. As the temperature rises, the pressure also rises. The higher the temperature, the higher the pressure. This relationship between pressure and temperature at constant volume is usually called Lussacs Law, in honor of the great French chemist. The force of steam pressure is what's going to make this train move. Now this train is really heavy. It has a mass of almost 400,000 kilograms. And there's a lot of friction in all those wheels and bearings. For us to get moving, it's going to take a lot of steam. By heating the steam in a fixed volume, we increase the pressure. And when the pressure reaches 12.6 atmospheres, we'll be ready to roll.
Wow. You mean that the pressure inside the boiler and the cylinder is going to be 12.6 times the pressure of the atmosphere?
Yep. Okay, the pressure looks about right. Come on over, pull this cord, we'll take her for a spin.
The direct relationship can be shown in a graph or a table. In the following examples, before the temperature of the gas is changed, P1 represents the first or initial pressure of gas, and T1 represents the first or initial temperature. After the temperature of the gas is changed, P2 represents the second or final pressure, and T2 represents the second or final temperature. The relationship between pressure and temperature is known as Lussacs Law. It can be represented by the equation P1 divided by T1 is equal to P2 divided by T2.